After the completion of the module, you will be able to describe ISUP functionality, understand the ISUP message format and significance of important parameters, explain various ISUP messages, describe various ISUP procedure like call setup, teardown, continuity test, etc. ISUP is used to set up and tear down all circuits used for data or voice calls in the public switched telephone network, PSTN, and wireless network. Two ISUP services are: Basic service provides the support for establishing and releasing connections for circuits within the network for the purpose of call. Supplementary services are all other circuit-related services, which typically encompass message transport after a call path is established. The called party number, CDPN, is the primary key for routing a call through the network. When using ISUP to set up a call, the CDPN can be sent using either Enbloc or overlap signaling. In North America, Enbloc signaling is always used. In Europe, overlap signaling is quite common, although both methods are used. The Enbloc signaling method transmits the number CDPN as a complete entity in a single message. When using Enbloc signaling, the complete number is sent in the initial address message, IAM, to set up a call. This is much more efficient than overlap signaling, which uses multiple messages to transport the number. Enbloc signaling is better suited for use where fixed-length dialing plans are used, such as in North America. Overlap signaling sends portions of the number in separate messages, as digits are collected from the originator. Using overlap signaling, call setup can begin before all the digits have been collected. When using the overlap method, the IAM contains the first set of digits. The subsequent address message, SAM, is used to transport the remaining digits. When using dialing plans that have variable length numbers, overlap signaling is preferable because it decreases post-dial delay. Figure illustrates the use of overlap signaling. Local exchange A collects digits from the user as they are dialed. When enough digits have been collected to identify the next exchange, an IAM is sent to exchange B. When tandem exchange B has collected enough digits to identify the next exchange, it sends an IAM to exchange C. Exchange C repeats this process. After the IAM is sent from exchange C to exchange D, the destination exchange is fully resolved. Exchange D receives SAMs containing the remaining digits needed to identify the individual subscriber line. The user data portion of the MTP3 signaling information field contains the ISUP message, identified by a service indicator of 5 in the MTP3 SIO field. Each ISUP message follows a standard format that includes the following information: the circuit identification code for the circuit to which the message is related, the ISUP message type for the message, for example, an IAM, ACM, and so on. Mandatory fixed part, required message parameters that are of fixed length. Mandatory variable part, required message parameters that are of variable length. Each variable parameter has the following form: length of parameter, parameter contents. Optional fields that can be included in the message, but are not mandatory. Each optional parameter has the following form: parameter name, length of parameter, parameter contents. ISUP message structure provides a great deal of flexibility for constructing new messages. ISUP uses a circuit identification code, CIC, to identify each voice circuit. For example, each of the 24 channels of a T1 span, or 30 channels of an E1 span, has a CIC associated with it. Because the CIC identifies a bearer circuit between two nodes, the node at each end of the trunk must define the same CIC, for the same physical voice channel. ITU defines a 12-bit CIC, allowing up to 4096 circuits to be defined. ANSI uses a larger CIC value of 14 bits, allowing for up to 16,384 circuits. The ISUP message type for the message. Each message type defines the mandatory parameters that are necessary for constructing a message. The mandatory fixed variables do not contain length information, because the ISUP standards specify them to be of fixed length. Because the mandatory variable parameters are variable lengths, pointers immediately follow the mandatory fixed part, to point to the beginning of each variable parameter. Lastly, there are optional fields consisting of name, length and content. Pointer to optional field is also part of mandatory variable part. The pointer value is simply the number of octets from the pointer field to the variable parameter length field. Here is a brief overview of some of the ISUP messages. IAM is Initial Address Message. This is the first message to initiate call setup. SAM is Subsequent Address Message, carries subsequent digits in case of overlap signaling. In case of Enbloc Signaling, IAM carries the complete digits of call party, else multiple SAM messages are exchanged to carry the subsequent digits. ACM is Address Complete Message. When the called party has been located, the terminating exchange sends ACM message to acknowledge the completion of the circuit and ringing applied. On receiving ACM message, the originating message applies ringback tone. ANM is Answer Message. When the called party answers the calls, ANM message is sent to mark the call setup completion and initiate conversation. CON is Connect Message. In case call is connected to auto answering or IVR application, the call connects directly, and there is no requirement for applying ringing. Hence, there is no requirement of ACM message, and a connect message is sent. CPG is Call Progress Message. His message is used to notify a distant exchange that some event has occurred during the progress of a call setup. The event is not a catastrophic or error-related event, but a call-related event. The events can be an alerting message was received, the call was forwarded because of a busy signal, and so on. COT is Continuity Message. Continuity testing verifies the physical bearer facility between two SSPs. The voice and signaling channels are usually on separate physical facilities, so it means verifying that the voice facility is connected properly between the SSPs is needed before establishing connectivity through signaling. REL is Release Message. His message can be sent by either of the sides to release the call. RLC, Release Complete Message, is sent by either side to acknowledge the REL message. SUS is Suspend Message. When terminating side goes on hook, circuit is temporarily suspended and it can be resumed by the terminating side by sending RES, Resume Message. Post-call setup, any further data or information exchange happens by sending INR, Information Request Message, being responded by INF, Information message. The IAM contains the information needed to set up a call. For a basic call, it is the first message sent and is typically the largest message in terms of size. Important fields of IAM message are: message type marked as IAM. Nature of connection identifier passes information about the bearer circuit connection to the receiving node. Forward call indicator provides call-related information in the forward path. Indicators such as call type, ISUP preferences and information, end-to-end signaling information, post-call setup, SCCP method used for called party number, etc. Calling party category indicating the subscriber is an ordinary subscriber or has language preferences or it is a test call. Called party number, and an optional calling party number. Format of both numbers are same except for presentation indication used in calling party number only. Fields of transmission medium requirement in case of ITU and user service information in case of ANSI, provide the requirements for bearer circuit capabilities. IAM carries other optional information, for example, information regarding invoking of intelligent network services during call setup, etc. The call progress message is used to notify a distant exchange that some event has occurred during the progress of a call. The event is not a catastrophic or error-related event but a call-related event. The event information parameter indicates what type of event occurred. An alerting message was received, the call was forwarded because of a busy signal, and so on, whereas the optional parameters provide additional support information required depending on the event. A destination node sends the ACM to indicate that a complete CDPN has been received. When Enbloc signaling is used to set up the call, the ACM is sent after receiving the IAM. When overlap signaling is used, it is sent after the last SAM is received. In addition to indicating the successful reception of the CDPN, the ACM sends backward call indicators, BCI, to signal information about the call setup. It is not mandatory for an ACM to be sent when setting up a call. It is permissible to send an ANM/CON after receiving an IAM. This is sometimes referred to as fast answer. The REL message indicates that the circuit is being released. When a RLC has been received in response, the circuit can be returned to the idle state for reuse. The REL message can be sent in either direction. It contains a single mandatory cause indicators field to indicate why the circuit is being released. SAM is used to send subsequent address signals, digits, when using overlap signaling for call setup. It has one mandatory variable parameter, the subsequent number. One or more SAMs can be sent after an IAM to carry subsequent digits for call setup that are part of a destination's complete telephony number. COT message contains the results of a continuity test. It has only one field, the continuity indicators. This field uses a single bit to indicate whether a continuity test passed or failed. The test's originator sends the message to the far end of the circuit that is being tested. The ANM is sent to the previous exchange when the called party answers. Although it might contain many optional parameters, the ANM does not contain any mandatory fields other than the message type. The RLC message is sent to acknowledge a REL message. Upon receipt of an RLC, a circuit can return to the idle state. Now, we will discuss few ISUP procedures. The SSP populates the IAM with information about the call setup, such as the CIC, CDPN, call type, CGPN, and PCM encoding scheme. The IAM information is placed in the user data field of the MTP3 SIF. The MTP3 information is populated based on the SS7 network information that is associated with the selected trunk group. The IAM is then transmitted onto a signaling link toward the destination, identified in the message by the DPC. SSPA starts timer T7, which is known as the network protection timer, or the awaiting ACM timer, to ensure that an ACM is received in response to the IAM. When SSPB receives the MTP3 message, it recognizes it as an ISUP message by the SIO service indicator bit. Then the message is passed to ISUP for processing, during which it extracts the message information. The CDPN and calling party category fields provide key pieces of information from the IAM for SSPB to complete number translations for this call. Ringing is now applied to the terminating set. ACM message is sent to the originating exchange to apply ring back to the originating set. Answer timing is usually applied at the originating switch to limit the amount of time an originator waits for answer. When the terminating subscriber goes off hook, an ANM is sent back to the originator to indicate that an answer has occurred. By this point, the voice path should be cut through in the forward direction to allow the conversation to take place. The call is now in the active, or talking, state. This is often a point of interest for billing procedures that require capturing the time at which a call conversation begins. For an ordinary call, no further signaling messages are exchanged for the duration of the conversation. When either of the parties goes on hook, it initiates signaling for the release of the call. The originator at SSPA goes on hook. SSPA recognizes the signal to disconnect the call and sends a release message, REL, to SSPB. SSPB responds by sending a release complete message, RLC, as an acknowledgement. The trunk member is freed and placed back into its idle queue to be used for another call. If the terminator goes on hook, while the originator remains off hook, there are two methods of handling the disconnection. The first method is for the terminating exchange to release the call by sending a REL message to the originating exchange. This is no different than the scenario presented for a release initiated at the originating exchange. The originating switch responds with an RLC, and the circuit is idled at each SSP. The other method is for the terminating exchange to send a suspend (SUS) message in the backward direction when it receives a disconnect indication from the terminating line. The SUS message provides notification that the terminating party has disconnected, but that the circuit connection is still being maintained. Suspending the call allows the person who receives the call an opportunity to pick up on another phone extension. When the SUS is received, the originating exchange starts a suspend timer, timer T6, or timer T38, in the case of an international exchange. If the terminating party reconnects, off hook, before the suspend timer expires, a RESM, RES, message is sent in the backward direction, allowing the conversation to continue. If the suspend timer expires, a REL is sent in the forward direction. In the event that the originator goes on hook, during the time the circuit is suspended, the originating exchange sends a REL forward, and normal call clearing takes place. The terminating exchange responds with a RLC. Continuity testing verifies the physical bearer facility between two SSPs. The voice and signaling channels are usually on separate physical facilities, so it means verifying that the voice facility is connected properly between the SSPs is needed. The actual circuit testing can be performed using either the loopback or the transceiver method. The loopback method is performed on 4-wire circuits using a single tone, and the transceiver method is used for 2-wire circuits using 2 different tones. The primary difference between the two methods is related to the action that takes place at the terminating end. When using either method, a tone generator is connected to the outgoing circuit at the originating exchange. Using the loopback method, the terminating exchange connects the transmit path to the receive path, forming a loopback to the originator. The originator measures the tone coming back to ensure that it is within the specified parameters. When the transceiver method is used, the transmit and receive path are connected to a tone transceiver that measures the tone coming from the originating exchange and sends a different tone back to the originating exchange. The initial address message contains a continuity check indicator as part of the nature of connection field. When an ISUP trunk circuit is selected for an outgoing call, and the exchange determines that a continuity check should be performed, the continuity check indicator is set to true. A tone generator is connected to the outgoing circuit, and the IM is sent to the SSP at the far end of the trunk. Timer T25 is started when the tone is applied, to ensure that tone is received back within the T25 time period. When the SSP at the far end receives the IM, with the continuity check indicator set to true, it determines whether to create a loopback of the transmit and receive path, or to connect a transceiver. The transceiver receives the incoming tone, and generates another tone on the outgoing circuit. The determination of whether to use a loopback or transceiver is typically based on provision data at the receiving exchange. Upon receipt of the IM, timer T8 is started at the terminating exchange, awaiting the receipt of a COT message to indicate that the test passed. The terminating exchange does not apply ringing to the call party, or send back ACM, until the COT message has been received, with a continuity indicator of continuity check successful, to indicate that the bearer connection is good. The originating exchange measures the received tone to ensure that it is within an acceptable frequency range and decibel level. Next, it sends a COT message to the terminating exchange to indicate the test results. If the test passes, the call proceeds as normal. If the test fails, the CIC is blocked, the circuit connection is cleared, and the originating exchange sends a continuity check request (CCR) message to request a retest of the failed circuit. While ISUP maintenance monitors the failed circuit's retest, ISUP call processing sets the call up on another circuit. To summarize, ISUP signaling takes place between SSPs or exchanges to set up, control and release the call. Between user phone and exchange, ISDN signaling is applicable. ISUP supports Enbloc and overlap address signaling suitable as per dial plans defined in various geographies, Enbloc being suitable for places where a fixed dial plan is followed like North America, and overlap suitable for variable dial plans like Europe, Asia, etc. ISUP signaling includes procedures for end-to-end signaling between the originating and terminating exchanges of a connection. The applications of ISUP end-to-end signaling are usually related to supplementary services. Continuity test procedure is carried to check for availability of voice circuit before call setup is attempted. In the United States, the generally accepted practice is to perform continuity testing on 12% of ISUP call originations, approximately 1 out of 8 calls. This percentage is based on Telcrity recommendations. This completes the module. Click Next topic from navigation menu.